Okay, now let's look at some examples on how to use stacks. We had just considered how we might implement a stack, which would essentially be a wrapper for STL list or STL vector, but to be honest with you, it's probably better if you're permitted to just use the STL stack class. So you'll notice right here when I say include angle bracket stack, this is calling the STL stack. This is including the STL stack library, and this is a container, and we can hold whatever objects we'd like. So in this specific example, we would want to show how we can reverse a string using an STL stack of characters. So as long as I've included the STL stack library, I can instantiate a stack by using the word stack, and you'll notice that I have the angle brackets. The angle brackets here is for whatever type of objects that are going to be contained in my stack. In this example, we have a stack of characters. So we have our stack of characters S, and then we prompt the user for a word. And once we get the word from the user, we store it in our string word. Now, in order to reverse this word that was just entered by the user, we will go through the word character by character and push each character onto the stack. Then, once we've pushed each character of the entered word onto the stack, we will print out the character from the top of the stack and pop it from the stack until it's empty. So let's just trace through what this looks like. So we start off with the empty stack, and suppose the user enters the word hello. So in the for loop, we would push each letter of hello onto the stack. So we'd push H, push E, L, L, and O. And this stack, this is after the for loop, so I'm going to put a star. This is what the stack will look like after the for loop. We go through the word one letter at a time, and we push each letter onto the stack. Now, for the while loop, what's going to happen is that it is going to pop first it will print out the letter, so it will print out, I'm going to put the arrow for what will print out. So print O, and then it will pop it from the stack. And then it will print the L, and it will pop it from the stack. And then it will print the other L and pop it from the stack. And then it will print the E and pop it from the stack. And then it will print the H and pop it from the stack. And then it will be empty. So the end of the stack will just be an empty stack. So as you can see, we would receive the word hello from the user, and we would print out O-L-L-E-H. And that is how we can use a stack to reverse a string. Now we'd like to consider another example of using stacks. And in this example, we want to consider how can we check if an expression is properly parenthesized. So here the only parentheses that we permit are square brackets, braces, and just parentheses in the opening and closing. So as you can see, an expression is properly parenthesized when each opening paren has a matching closing paren. And when we use a stack, we will consider the last parentheses to be the first to be completed. So before we do a trace of when we know an expression is properly parenthesized or not, let's consider our general approach. So what we'll do is, given an expression, we will scan it character by character, and any character that is not a parentheses, we'll simply ignore them. Then, for each character that is an open paren, we'll push the open paren onto the stack. When it is a closing paren, we'll check the top of the stack. If the top of the stack equals the matching open paren, we'll pop it from the stack. Otherwise, we'll report error immediately. If there are no characters left in the expression string and the stack is empty, we will accept the expression as properly parenthesized. Otherwise, if there's no characters in the string but there's characters on the stack, then we know we need to reject that expression. Now let's consider a trace. Now we want to trace two improperly parenthesized examples. So the first is parentheses 7 star E. So I start with an empty stack. I see the left paren. I push it on to the stack. I see 7 star 8. I ignore them. So then my expression string is empty and stack is not empty. So expression empty, but stack not empty. So we have to report an error. Now let's consider the second example where we have a left parentheses with the matching right bracket. So now as we scan through our expression string from left to right, we start off with an empty stack. We push on the left paren. We ignore the 7, the star, and the 8, and then we come across the right bracket. So we check the top of the stack. Top does not equal the matching left bracket, so we report an error. It is the incorrect opening paren. Now let's see what happens when we have an expression which is properly parenthesized. Okay, we start with an empty stack. We push the left paren. We ignore the 7 and the star. We push the left bracket. We ignore the 8 and the plus. We push the left bracket. We ignore the 9 and the division symbol. We push the left brace. We ignore the 5, the minus sign, and the 2. And finally, you see, we come across the right brace. So now we check the top. Top equals the matching open paren. So then we pop. When we do so, we just have the 2 left square brackets above the left paren. Then we come across a right bracket. So the top equals the corresponding open paren. So we pop. And once again, we come across a right square bracket. So the top equals the matching left bracket. So we pop. And the stack will just have the left paren. And finally, we come across the right paren, and we see that the top is equal to the matching left paren, so we pop, and when we do so, we have an empty stack. So here we have an empty stack and an exhausted expression string. So we can just return except or true, or however we are implementing it. Now, let's consider how we may evaluate mathematical expressions using a stack. So we want to think about how we can modify the approach that we had just used for checking the parentheses of a mathematical expression. So how can we modify this? So we can scan the expression string once again from left to right, character by character. But now, rather than ignoring characters such as numbers and operators, we push them all into the stack. Then, when we encounter a closing paren, such as the right paren or the right square bracket or the right brace, we pop until we find the matching open paren. So then what we need to do is, once we've found the matching open paren, we evaluate the expression popped and we push that value onto the stack. If we happen to have a malformed expression, then we would reject if we didn't find an opening paren. So a couple things to consider, and this is an implementation detail that you would need to figure out, is what do we do with this expression that we're popping that we need to evaluate to then push onto the stack. So I'm going to do a little trace now of an expression, and then this is what I would like you to think about, how you would actually implement this. So we start scanning from left to right. So when we scan, I push the left paren, then I push 7, then push star for multiplication, then the left square bracket, 4, plus sign, 2, plus sign, and 3. And this is the result of just scanning the expression from left to right and pushing everything onto the stack until I find the first right paren. In this case, it's a right square bracket. Once we do that, what we need to do is then we need to start popping. So we would actually now put this here, and we should store this. We would store the 3 and pop it, and then store the plus and pop it, store the 2, pop it, store the 4 and pop it, and then we found the matching left bracket. And when we found that, we would stop popping, but we would have to evaluate this expression. When we evaluate it, we'd see that the value is equal to 9. So then we would push the resultant value, 9, onto the stack. And then we would continue our evaluation of the expression string. But one thing I'd like you to consider is, how would you like to store this sub-expression that you're popping from the stack and deciding whether you'll evaluate it or not, and then push the return value from the evaluation back onto the stack? So that's a decision that you could make based on how you'd like to implement this. So now we've pushed the evaluated value back onto the stack, and now we go back to expression string. You'll notice that the next character in the expression string is the right paren, in which case we repeat the process. So we have to pop the 9, pop the multiplication sign, pop the 7, and then you'll notice that we hit the matching left paren, in which case we know we have to evaluate this expression. And you'll notice that before we evaluated, we will have popped the left paren, so the stack will be empty. we evaluate this expression, 9 times 7. You know that the value is 63, so we push 63 onto the stack, and you'll notice now that the top of the stack, in fact, the only value on the stack, is the value for our mathematical expression. So if you were to implement this, you will need to consider what would you do with these intermediate expressions that you are popping and need to evaluate to push back onto the stack. Some consideration could be you could use another stack to keep track of it. So that's something for you to consider how you might implement this.